Okay. Um, so let's take a look at. I hope I have the right thing attached. Can you guys see solving the system using technology?
Yeah.
Great. Okay. So today's lesson is just going to be. There's nothing new today, really. We're just going to explore using technology in a more detailed way, which I didn't really do yesterday. I gave you. I told you how to use it, but I want to go in more into detail because I believe that we're probably going to be taking the state exam. If we take it, it's going to be an electronic format. So that means we're going to be relying on technology even more than in past year. So we can use what we learned yesterday to solve, especially the more complicated problems. So I'm going to go through, all the details on that. So how can you represent algebraic expressions using a coefficient matrix? We did this yesterday in a sense. We solved a few problems using it. So we're going to be using something called Desmos matrix, which you saw me do the other day. Okay. I selected this one because Desmos, we're already using it, okay, for other things, and it's very convenient for us to use. It's user friendly, so it's easy, and it's also available on. It's an app that you can have on your phone, or you can run it off of an internet browser, the way I did yesterday. Just do a Google search, and it comes right up. Okay, so that's why I chose this, for the ease of use, really. Um, what we're going to be doing sort of like yesterday, is we're going to write augmented matrices for systems of linear equations. Okay, and yesterday I gave you all ones that were worked out in standard form, and somebody asked me, can I do one that's not in standard form? And the answer is yes. We're going to see questions today where they're not in standard form. We have to create it, put it in standard form ourselves first before we go to the computer. So that's the real reason behind me doing today's lesson. I want you to see how that works. Um, and then, of course, we're going to use technology to solve systems of linear equations in three variables. That's the goal. And that goes back again to using Desmos matrix. Yes, you can use other applications. And yes, if you had one, you could use the TI 83 or 84 or any of the plus versions, okay, like the 89 and stuff like that. But we're not in the classroom. So normally I would hand these out and have you use them. So I'm going to be using Desmos instead. And honestly, I prefer Desmos to using the TI calculator. I think it's easier to use than the calculator is. All right. And here you have to deal with menus and sometimes things get hidden. And with Desmos, everything's right in front of you. So it's just easier. Okay. Anyway, um, what is a matrix, which we saw yesterday? A matrix is a rectangular arrangement of numbers. So there's an example, okay? And I didn't go into specifics yet. The dimensions of a matrix with m rows and n columns are m by n, okay? So basically, the one you see below here is a 2 by 3 matrix because you have row one, row two, and then you have three columns. This is the first column, the second column, the third column. So we call this a 2 by 3 matrix. Okay, that's where that comes from. That just tells you how many rows and columns there are. And what I love about Desmos is that stuff is directly in front of you. It's right in front of you when you go to enter the data. It's right there. You're not going to have any issues. Okay. Um. So again, this is just a 2 by 3 because you have row one, row two, and then you have column one, column two, and column three. Okay. And here's how you write coefficient matrices. Okay, and it's pretty simple. Now I'm going to show you the ones that are not that are more complicated in a minute, but the ones we saw yesterday were like this top item. Okay, it's x, y, z. So if it's x, y, z, this is 2 for x, 1 for y, and 6 for z. Okay, that's where this comes from. 2 for x, 1 for y, 6 for z. Now, the one underneath, this is where students get in trouble, and I get a little worried here, and we got to be super careful. Um, you're going to notice something's missing here. Can somebody tell me what's missing from this expression down here?
The
A
Y.
Y.
The y is missing. Really, what this says is this. It really says negative x plus 0y plus 3z. Okay? It's really negative x plus 0y plus 3z. So I need to ensure that I put a 0 where in the y position. And this is okay because 0y is 0, right? So it's the same as what they have written. If you write 0y, you're writing this. But the computer won't understand. The computer needs the 0. The computer cannot assume 0. If you put in -1 and then 3, the computer thinks you're making x -1, which is correct, and then you're making y 3, which is not true at all. Okay? It should be -1, x is -1, y is 0. The coefficient for y is 0, and the coefficient for z is 3. I hope that's making sense. So you have to make sure that everything is x comma y comma z. You cannot skip. If something's missing, the coefficient is 0 for the missing item. This is super important. I'm going to keep doing this throughout the period, okay, until we get comfortable. Um, in this next one here, again, okay, you'll notice that y is missing. So this is technically 4x plus 0y minus 3z, okay? Because y is missing, you have to write the 0 there. So 4x, so the coefficient for x is 4, check. The coefficient for y is 0, check. And the coefficient for z is -3, check. Okay, somebody want to tell me what's missing in this line here?
Z.
Z is missing. So really, it's 5x minus 1y. I like writing the 1. I'll put the 1 there. And then 0z. Okay? So 5x minus 1y plus 0z, which means I have 5, I have -1, and I have 0. That's where those values come from. Okay? And now finally, I'm going to do the last matrix that has 3 things in it. Okay, so let's do this last one. Okay, so you have 3 different equations. 1, 2, and 3. Okay, there's your 3 equations. Now, I am happy with my first equation because it's got x, it's got y, and it's got z. So this is like what I saw yesterday. I can just substitute 4, then 2, then 3. So that's correct. I want someone to tell me what's wrong with 2.
X is missing.
X is missing. So really, it's 0x plus 3y minus 1z, right? So 0 goes in for x. See that? X is missing, 0 for x, positive 3 for y, and -1 for z. That's correct. And anybody want to try 3? What's missing in 3?
X and Y.
X and y. So this is really the same as 0x and 0y. It's missing both, and then 4z. So it's 0 for x, 0 for y, and then 4 for z. Okay, and this is how you have to kind of work these out. Okay, you can't have missing parts. If something's missing, it's 0. Okay, you can't just leave things out. The computer won't understand. If you just write down 4, right, the computer will think you're making 4 the coefficient for x, which is not what this says. 4 is the coefficient for z. So x and y are zeros. It's just z that's 4. Okay, the coefficient for z is 4. Before I scroll to the next page, are there any questions on anything here at all? Any questions? Anything? I'm going to assume if there aren't any questions, then that we're okay. I'm assuming we're okay. Yeah. Okay. Let me run through and go to the next page then. All right. And there's a little more review of this on the next page. So if you missed it, you're going to get to see it again in a second. Okay. So more on writing an augmented matrices for the system. the augmented matrix or the augmented matrix, this is what's going to be substituted into the computer. So we need to convert whatever it is we have into an augmented matrix. Now, the augmented matrix that I created in the last example, these are them. This right here, this is considered an augmented matrix. It's considered an augmented matrix because this is what I'm going to be substituting into the computer. Okay. So the coefficients, right, in this form is considered the augmented matrix. All right. So I have to convert, if I want to use technology, I have to convert all my problems into an augmented matrix first, and then I can substitute it into the computer and then let the computer solve it for me. Okay, so writing an augmented matrix for systems. Um, a matrix is a rectangular arrangement of numbers. We know that already. The dimensions of a matrix with m rows, so in this case, there's one, two rows, and n columns, in this case, there's one, two, three columns, is read as m by n. So technically speaking, this would be a 2 by 3. So the dimensions of matrix A are a 2 by 3 because you have two rows and three columns. The numbers in the matrix are considered, they call those the elements. So the things inside the matrix or matrix are the elements. So if we wanted to, we could call out elements. All right. I'm not going to have you do this, but when you take the next course, right, it's possible to, you should know what the elements are. For example, if we said the element in the first row and third column. So row one is up here, and this is column three here. So five would be the answer. The first row and third column is five. If I said the first row and first row, first column, the answer would be four. If I said second row, first column, second row is down here, and first column is right here. Second row, first column, that'd be zero. If I said second row, third column, again, second row is down here, second row, third column, that's here, second row, third column would be three. This is just being able to label off where each thing is located. I'm not going to be asking you to do that, but it's just the way we label each element. If you wanted to call them off, you could do that. So if someone said to you, please identify the second row, second column, or the element in the second row, second column, you'd go to the second row, which is down here, and the second column, which is here, and the answer would be six. Okay, that's just how you label the elements. All right. A matrix derived from a system of linear equations, very important. Each written in standard form with the constant term on the right. It must be written in standard form, or you're gonna get it wrong. So a matrix derived from a system of linear equations, which must be in standard form, is the augmented matrix of the system. So that's converting from what you see here to what you see here. For example, the system below can be represented by the given augmented matrix. We saw this yesterday. This system, and yesterday I gave you all systems that were already in standard form. I gave them to you in standard form. That will not be true today. You're going to have to create them on your own sometimes and put them in standard form. Somebody asked me that in class yesterday. I'm not sure if it was this class or my morning class, but I'm going to answer that question in both classes anyway. It's an important question. So the question was, what do you do if it's not in standard form? Well, give me a couple of minutes. We're going to answer that. First, let's look at one that is in standard form. And this one is in standard form. And let me explain why it is in standard form. Okay, so understanding if something is in standard form, it has to have X, Y, Z, and then the value. X, Y, Z, then the value. X, Y, Z, and then equals the value. These three equations are all in standard form. They all have X followed by Y followed by Z, and then they have equal to a value. So these are all currently in standard form. So once they're in standard form, it's super easy. You can just change it into an augmented matrix. So for the top row, it's 5, +3, -2, and then 1. Pretty simple. For the second equation or second row, there's an invisible 1 there, so it's 1, then it's 2, then it's 3, and then -1. And for the third equation, it's +3, it's -4, right? It's +1 followed by 10. Okay, so that's basically this. Okay, that's basically this. All right. Um, Before you write an augmented matrix, you have to make sure each equation in the system is written in standard form. So, and I've done that. I've ensured that this is in standard form, and then I translated it into the augmented matrix. Okay. Include zeros for the coefficients of any missing variables. We did that on the last page. We made sure we did that. This determines the order of the constants and coefficients in the augmented matrix. So it has to be in standard form, and you have to put zeros if stuff is missing, okay, which we saw already. So we're going to do an example now together. This is kind of an easy one in that there's only two equations and two variables. So it's not the one with three. We're going to see the one with three in a minute. So the question is not to solve this. We want to write an augmented matrix for the system, then state the dimensions. So I write an augmented matrix for the system and then state the dimensions. So, okay, remember what I said. It's got to be in standard form first. This one is not using Z. This is an X and Y only, so we're not going to make Z 0. This is one with only two variables. So this is a two variable question. There's no Z in this one. Okay, this is the easier type. Okay, so if it's going to be two variable, we need X, then Y, and then equal to the solution. So if you look at this, um, the bottom one to me looks good. Somebody want to tell me what's wrong with the top equation? Something's wrong with it.
The Y is coming before the X.
The Y is coming before the X. Can you help me rewrite this? How should it look? How should this look?
-2x plus 1 plus y equal 1.
I agree with that. -2x plus y equals 1. We need the x to go before the y, just like this. So he put the -2x in front of the y, which is perfect. Okay, you're allowed to do that. This one I'm not going to change because this one's already good. It's just x plus 3y equals 12. There's no need to change it because everything is proper. Everything is good. So now that we have our things written in standard form, let's now write the augmented matrix. So somebody want to write what should I put up here?
-2,
-2. Good.
1,
Yep.
1,
That's it. -2 for x, 1 for y, and then 1 for the solution. Perfect. Somebody want to give me the bottom equation as in the augmented matrix?
1,
1.
3, 12.
Thank you. Okay, 1 for x, 3 for y, and then 12 for the value. And then if we wanted to, I'm not going to solve this one in the computer, but you could put this in and you could solve this augmented matrix with Desmos matrix. Okay, I don't normally recommend doing a matrix for something that with two variables and two equations. I personally think this is overkill. You could just use graph a line and look for where they intersect. Okay, I did this just to show you that you can use a matrice to solve a two variable, two equation system, but I don't think that's really necessary. You don't need to do all this for two variable and two equations. You can do it other ways that are probably easier. But if you wanted to, you could do it this way. So I'm not going to spend any more time with two variables and two equations because you've had so much experience with that in other courses and there are other ways of doing it. I'm going to really now focus on the questions with three variables and three equations because those you can't really graph. They're tough, right? You can't really graph them on a normal calculator. So you have to use another technology, and that's the matrix. So what I really care about are these, okay? The ones with three. Now, the good thing is the ones with two, the strategy is still the same. It doesn't change the work. It's just now that there's more. So it was worth just exploring this just to see how to do it. So here, again, before we can go write an augmented matrix for the system, we have to put it in standard form first, okay? That has to come first. And if you look at this, to me, it's clearly, they're not all in standard form. They're not. If I look at the first statement, it's not in standard form. Somebody want to tell me what's wrong with the first statement? Why is it not in standard form?
Z is on the opposite side of the equal sign.
Yeah, the Z is on the wrong side. Do you know how to bring it to the other side? Anybody have any ideas how to bring it over here?
You
How do I get this? Yes. Okay. When I add it, I'm going to end up with 3x minus 4y plus 2z equals 7. Now, for anybody who's having confusion on what was done here, I'll show the work down here, okay? We have 3x, and this is just for people who are having trouble. 3x minus 4y equals 7 minus 2x. What you can do is you can add 2x to each side of the equation to get, sorry, 2z. I'm sorry. It's not an x, it's a z. My bad, my mistake. Okay, you can add 2z. You can add 2z to each side of the equation. These cancel. If you add 2z over here, you end up getting 3x minus 4y plus 2z equals 7. Okay? So basically, I just took the negative 2z, brought it over here, and made it positive. Okay? That I didn't show the step. I did it. We did it mentally. But if you want to show the work, feel free. You can. You don't have to. You could do it mentally if you want. So that's statement one. Statement two. Is anything wrong with statement two?
There is no Z.
There's no z, so I can't leave it like that. I'm going to rewrite it as 9x plus 3y plus 0z, right? Okay, I have to put something there for z. 0z equals 3. I would say it looks good now, right? Now this is in standard form. Both of these are in standard form now, so I'm happy. What about the third one, the third equation, or the third row? Is the third row okay?
Yeah, it's correct.
Yeah, it's good, right? It's not. It's in standard form already. So I could just rewrite it. I could just write 2x plus 4y minus z equals 2. So now I have all my equations in standard form. And now I'm ready. Now I'm ready to rewrite this as an augmented matrix. Okay, once I get the standard form, then I can write it as augmented matrix. So again, somebody asked me yesterday about what happens when it's not in standard form. Well, what happens is you have to convert everything into standard form first. Then, and only then, should you be writing out your augmented matrix. So this has to happen first. Now you go to the matrix. So somebody want to give me the values to write? I'll do the first one. I'll let somebody do the other ones. So the first one would be 3, negative 4, 2, and then 7. That's my first row. Somebody want to give me my second row?
4.
I'm sorry, I can't hear you.
It's 4.
That's
Oh,
a 9.
it's 9. 9. I'm sorry. It's 9, 3, 0, 3.
Thank you. A very important thing that he mentioned was that 0. That 0 must be there or it's not going to work out. You have to put the 0 there. So this is why converting to standard form is so important, okay? And then let me get somebody for the last row or the last equation.
2,
2,
4, 1.
-1, yes.
Oh yeah, 2.
Thank you. That's everything. There's my matrix A. And I didn't state the dimension. I'm going to solve this. I'm actually going to use the computer and solve this one. But they also want me to state my dimensions. So my dimensions here are, well, there's row 1, row 2, row 3. I have 3 rows. That doesn't look good. I have 3 rows. And I have 1, 2, 3, 4 columns. So I have a 3 by 4 matrix because I have 3 rows and I have 1, 2, 3, 4 columns. So that's what I have thus far. Okay, a 3 by 4. Now to actually solve it. Well, we learned how to solve it yesterday. I'm going to do it again. I'm going to put this into Desmos and solve it. And let's get the values for X, Y, and Z. Let's go in Desmos and do it. Okay, let me load up. Okay, so at this point it should be loaded up. We should be able to see Desmos. Let's drop in, let's make a new matrix. So step by step, you log in or just load up Desmos /matrix. You can run a Google search on it, it'll come up. If you're using a cell phone, it's also an app that you can put on your phone and you can do it that way too. So it works pretty much everywhere. It's very convenient and it's really easy to use. So I want to make a new matrix. Okay, just click on that. And you'll notice that this is not big enough to hold my information. So I'm going to let somebody tell me what they think I should do. What should I do first? I can't put my information in because this matrix is too little. Anybody have any ideas?
Increase
Edit the
one
matrix.
row.
Yeah, let's increase the matrix, right? I have to make rows 3, right? 3, 1, 2, 3, and I got to make columns 4, right? So I
Yeah.
have row 1, row 2, row 3, and I have column 1, column 2, column 3, and column 4. Now I have a matrix big enough to hold all my data. Okay, so now it's a 3 by 4. So I'm going to put everything in there. Let me look back. The first row was 3, -4, 2, 7. So 3, -4, 2, 7. That's the first row. The second row, 9303. 930. Yes, you must write the 0. 9303. And then the last row was 2, 4, -1, 2. 2, 4, -1, and 2. Okay, so now everything is in. Okay, all my values are in. All right, so once I get that stuff all entered, I have to hit the enter key, which is this blue key in the bottom right hand corner. So I enter my information. Now it's in Desmos. Okay, it's in there. And what I want to do is I want to solve, and I'm going to show you in the notes in a minute, but RREF, reduced row echelon form, this solves. So you click on this, and then you put the data where A was in matrix A. So you click on A, and now if you look to the right, you'll see the values. One value of X, one X without Y, without Z is -1.4. No X's with one Y with no Z's. In other words, in English, the first line is X alone. One X by itself is -1.4. One Y by itself is 5.2. And one Z by itself is equal to 16. So these are my answers. It's -1.4, 5.2, 16. Let me just write this down. negative 1.4, 5.216. Okay, let me bring us back to Desmos. I mean, back to Smart Notebook. Okay, so that's the solution. Okay, negative 1.4, 5.2, 16. Okay, so that's your X value, that's your Y value, and that's your Z value. Okay, so if you want to list it, you could list it as X equals negative 1.4, Y equals 5.2, and Z equals 16. Normally I write the answer just like this because this is the same as this. Okay. Questions or we're okay? Any questions at all? No?
No.
Okay. All right, great, great, great. So I'm assuming that we're good. Um, let's finish this off. Okay. We're moving right along. So let me just make sure I typed the right thing. Hang on. I think I made a mistake. A window, and it should be this. Okay. Okay. All right, it's loading back up. Hopefully now it's coming in clear. All right, so solving systems of equations using technology. So I just did this, but they're going to walk us through what happened. Many technology tools have matrix features that you can use to solve a system of linear equations. The augmented matrix in example 2, rewritten in reduced row echelon form, is shown below. So if you notice, when I use the calculator, I hit the button RREF. Okay, that's how you solve. RREF stands for reduced row echelon form. Okay, that's what it stands for. And this is shown below. Observe the solution to the system, and this is the same answer I have. Negative 1.4 right there, 5.2 right there, 16 right there. So we saw this with the computer. You can verify the solution in the original system. Please, please, please make sure it looks like this. You have to have, this means 1x without y without z. This means 1y without x without z. This means 1z without x without y. Okay? I'm determining that because where the ones are located, which position. Remember, this is my x column, my y column, and my z column. Okay, so that's how I know that. This is 1x, no y's, no z's. There's the answer. No x's, 1y, no z's. The answer. No x's, no y's, 1z, and there's the answer. I hope that that's okay. So you have to make sure the computer gives you this, all right, before you write down your values. If it doesn't give you this, then either the question had no solution or the question had infinitely many solutions, and then you're going to have to do a hand manipulated approach where you're using the other techniques like elimination or substitution where you solve it algebraically, which I showed you the last couple of days. So yeah, unfortunately that will happen sometimes and you have to do it by hand. Okay. I also added the steps for doing this. I'm going to post this to Classroom so you could have it. Step 1 is to write an augmented matrix for the linear system, but it has to first be in standard form. So you have to make sure it's in standard form. So write an augmented matrix for the linear system. The augmented matrix means you do this. Okay, you just take the coefficients and you write this and put it in the computer. But to do this, you need to have standard form first. Enter the augmented matrix into your graphing calculator. Well, no, we're going to enter it into Desmos. We're going to put ours into Desmos matrix instead. Okay. Use the reduce row echelon form feature to rewrite the system. And yes, we do that. After we put it in, we use RREF. That's that button. interpret the result from step 3 to solve the system. So you use what you see here to get the answer. And then provided everything is right, this is X, this is Y, and this is Z. Okay? We're going to look at maybe 1 or 2 more quick things, and that's going to be it for the day. All right. So this was just really about, I want you to be comfortable using the technology to solve, because I believe that it's going to play much more of a role this year than it did in previous years, especially being that we don't have traditional instruction. So technology is going to be a much heavier focal point. It was already a heavy focal point before, but now it's going to just be essential to know how to do. So here we go. They want us to basically use a graphing calculator to solve this system, and we're just going to use Desmos. We're not going to listen to them. Okay, I think these are all in standard form. So this one's kind of easy. Somebody just want to give me, since it's already in standard form, somebody want to just convert this into an augmented matrix. I just want the first row or the first equation.
1, 1, 1,
1, 1, 1.
2.
Agreed. There's a 1 here, a 1 here, a 1 here, and then a 2. Agreed. Somebody else want to give me the second equation?
2, 3, 1, 3.
2, 3, 1, 3. Okay, and then I'll take the final equation. Somebody else for this bottom one?
1, -1, -2, -6.
Perfect. Okay, so that one was pretty easy. And then you could just dump this into the calculator, and I'll do it one more time. I want to show you one more after this, so you got to manipulate it. I'll do this quick. You can dump this into the computer, and then it's going to give you the value, right? So I can go to Desmos if I want. And let's quickly go to Desmos, and let's make so now we're in Desmos, right? We're in Desmos, we're going to make a new matrix. Again, you're going to notice that this is too small. So you have to fix it so that you have 3 rows and 4 columns. Okay, now you can input your data. And my data is 1, 1, 1, 2 for the top. 1, 1, 1, 2. There's my top line. My next line is 2, 3, 1, 3. 2, 3, 1, 3. 2, 3, 1. Oops. 1 and 3. And then my bottom line or row, 1, -2, -2, sorry, 1, -1, -2, -6. 1, -1, 1, -1, -2. And of course, you have to make sure you put the negatives if there's a negative there. So 1, -1, -2, -6. That's my matrix. I'm going to enter my matrix with this blue key right here. So now, and matrix B is now entered, and I'm going to use RREF, reduced row echelon form. Okay, I'm going to click on this, and I put my information in B this time, so I have to click on B. Okay, and now my answers to the right, I noticed that I got what I need. I have 1, 0, 0, 0, 1, 0, 0, 0, 1. So everything works out the way it's supposed to work out, and that means 1x, or x is equal to -1, y is equal to 1, and z is 2. So -1, comma 1, comma 2 is going to be my solution. -1, comma 1, comma 2 is my solution. So that is what I have, again, -1, comma 1, comma 2. Okay, this was not a hard one. This was like what we saw in class yesterday, so there's not really much that you have to do when the questions are ready in standard form. I think those are easy. Or easier. It's when the question is not in standard form that people get in trouble. So with the last example that we're going to do today, I want to do example 6. I'm choosing example 6 for a reason, because 6 has manipulation. As you look at it, you'll see what I mean. So let's just look at example 6, and then we're going to stop, and I'll be in the exact same place that I was in my morning class. So, okay. The question is, are all three of these equations in standard form? Let me ask the class data. Are all three of these equations in standard form?
No.
No, they're not. They're not. The good news is, statement one, the first equation, or okay, the first equation is it's got x, y, z, and a solution. So 3x, this one's okay. This is the only one that's okay. 3x plus 2y minus 5z equals -10. Okay, the second statement. So this is statement one over here. Statement two. Somebody want to help me with statement two? What's wrong with it?
Y is missing.
Y is missing. So how do I write this? How do I write this if y is missing? What do I do?
0y.
Hmm?
0y.
0y. So 6x, then I have to put 0y, right? Because y is missing, minus z equals 8. That's correct, okay? And again, I believe the last equation is not in standard form either. So I just need help. What should I do for the last statement? What's wrong with it?
0x.
Yeah, 0x needs to go there. So I have 0x minus y plus 3z equals -2. Okay, 0x minus y plus 3z is -2. Now it's in standard form, and now we're just going to write the augmented matrix, and then we're going to be done for today, okay? So let's get an augmented matrix for what we see here. Somebody just want to give me the top row of the augmented matrix?
3, 2, -5,
3, 2, -5, and don't
-10.
forget, and -10. Okay, let me get somebody else to give me the second row of the augmented matrix.
6, 0, -1, 8.
6, 0, -1, 8. Thank you. Very good. That's the second row of the augmented matrix. And then finally, we'll take the third row, and then we could dump this into Desmos and get the answer.
-1, 3, -2.
Okay, don't forget though, you're 0, okay? So
Oh,
0, -1,
3,
3.
-2.
Okay, the computer will not assume 0, right? We have to tell the computer that the x coefficient 0. So we have to make sure we put the 0 there, okay? If you don't put it, it's going to think the -1 is x and the 3 is y and the -2 is z. It's going to shift everything. So we have to make sure that we're very careful about putting these zeros in. All right, that's why I like this question. It makes sure that it forces you to be careful. So if we solve this, once we get this, it's pretty easy. You're just copying this into the computer, which I'll do really quick, and then we'll be done. Let me go to back to Desmos. Okay, so let me make a new matrix. Okay, so I'm in Desmos. I'm making a new matrix. Again, this is too little, so I have to add a row, and I have to add 2 columns. Now it can fit. So my first row is 3, 2, -5, 10. 3, 2, -5, and 10. The next row was 6, 0, -1, 8. 6, 0, -1, 8. And then my final row was 0, -1, 3, -2. -1, -1, 3, -2. Once you get all your data into the matrices, just hit enter. And now once that data is entered into the computer, now you're using RREF, or reduced row echelon form. That's what it stands for. And we use variables. We use C this time, so C. And here we go. We have 1, 1, 1. Everything is right, right? We have 1, 0, 0, 0, 1, 0, 0, 0, 1. Everything came out right. These are my values: 1.56, 6, and 1.3. 1.56, 6, and 1.3. And that's it. Okay. So that was the final thing for today. We finished everything. Um, tomorrow will be like we'll start doing some review, and Monday will be review, and the assessment's going to be next week. Most likely Tuesday, possibly Wednesday, but most likely Tuesday. Okay. So that's everything. I don't have anything else. If you have any questions, you could ask me now, or you could send me an email, whatever it is that you want to do. And there'll be a review session tomorrow at the end of the day. I'll make an announcement in class again, and I'll post a link to it. So that's it. We're done for today. Please be safe and enjoy the rest of your day. Okay.
I have a question.
Sure.
Okay, bye.
When
Bye.
do you do office hours? Because the third homework question, it's causing me headaches.
Okay, no problem. So tomorrow, let's say 2:15, 2:15 to like 3.
Okay.
Okay. Just remind me and I'll set the link tomorrow. Okay.
Alright.
You know what it is? I can't do the sessions on Tuesday, Wednesday, or Thursday because I teach college now.
Okay.
That's why. So I teach after school today. But tomorrow, Monday, and Friday are the days I can do it. So I'm going to do Friday. Okay. Just remind me tomorrow and I'll put the link. I'll post the link in the chat. Okay.
Alright.
All right. No problem. I'll help you with it. It's no big deal.
Okay.
All right. I'll see you tomorrow in class. Okay. All right. Bye.
Bye, Mr. Rampezi.
Bye, Mayasia. I'll see you tomorrow.